Hello everyone. This is the pre-lab video for Lab 3, Organic Molecules, Building Organic Molecules for Chem 100 Chem for Life Sciences class. So in this lab, you're going to be modeling or building organic molecules using some building materials. So we'll use toothpicks as our bonds and we'll use marshmallows as our atoms. The large marshmallows represent carbons, the small marshmallows representing hydrogen atoms. You can find substitutes for any of these materials if you'd like. You could use dried spaghetti noodles broken up as toothpicks or unfolded paper clips. You could use berries or Play-Doh as your atoms, as long as they're different sizes to represent carbon is larger than hydrogen, right? And you're going to connect them using our bonds, our marshmallows, if you will. So we can connect 4 things to each carbon, right? Carbon has 4 bonding arms, and hydrogens only have 1 bonding arm. So that's important in your Lewis structures and in your 3-dimensional structures as you build them. So I could build a very simple alkane here, the molecule methane, which has 1 carbon and 4 hydrogens bonded to it. If we want to add more carbons to our structure here, we have to add them carbon to carbon, right? We can never put a hydrogen in the middle. Hydrogens always go along the periphery of our molecule. So make sure that you are, respecting the octet rule, that the hydrogens only have 1 stick coming out of them. The small marshmallows only have 1 stick, so hydrogens only have 1 bond, and that each of the carbons needs to have 4 sticks coming out of it, or 4 bonds. Right? In this lab, you will be building a large alkane. I think a decane is the one that I have instructed you to build. In this case, I have a smaller one. I have built pentane here. So there are 5 carbons and 12 hydrogens for a straight chain alkane known as pentane. All right, let's see if I can angle this down a little bit to see our molecule here. So in this lab, you're going to build a straight chain alkane. You're going to then draw the Lewis structure on your page. You'll also draw it in condensed structure and in skeletal structure. And then you're going to rearrange the molecule to make some isomers. An isomer is a molecule that has the same chemical formula, so the same numbers of carbons and hydrogens, but a different structure. So the easiest way to do that is to pluck off a carbon group. This would be a methyl group, a CH3 or a methyl group, and a hydrogen somewhere on one of the middle carbons. So I'm going to pluck off this hydrogen here, and we're just going to swap spots. So I'm going to put this hydrogen here and this carbon group over here. And now, I don't know if you can see this very well, now what we have is a branched chain alkane. We have a parent chain of 1, 2, 3, 4 carbons, so that's a butane, and sticking off of this carbon number 2 is a methyl group, so this would be 2-methyl butane, and that is an isomer of pentane because all we did was we rearranged pentane. They have the same number of carbons and the same number of hydrogens. So in this lab, that is what you're going to be doing. You're going to be manipulating some marshmallows and toothpicks to build some models of organic compounds, practice drawing them on paper, and practice naming them, and practice rearranging them manually. Do make sure that you take a photo of your models to show me that you did do the activity, the physical manipulation activity, so I can give you credit for that. And that's all. Have fun.